it is a review for exam number 2. Exam number 2 will cover sections from 6.2 to 7.3. Okay, let's go to number 1. Use the shell method to find the volume of the solid obtained by rotating the region bounded by the given curves about the x-axis. For this problem, you will have to understand the problem, and then the volume can be obtained integral of 2 pi r and shell height. This is the shell area, and you can integrate over x and over y, right? And that means, okay, it is a little bit confusing. So then dx or dy, okay, over x or over y, okay? Okay, now let's try to understand the problem. And here we have a coordinate axis, and y equal x squared. And here y equal 0 is x-axis, and x equal 2. Okay, so the region bounded by these 3 curves that is rotated about the x-axis. Now we want to find the volume of the solid by using shell method. So here, because it's rotated about the x-axis, now here each line segment, that one is rotated, then it will make a shell. So here the volume computation must be y integration. Okay, when x equal to y value will be 4, so it's a 0 to 4 integration, and then now for each y here, for each y, now the radius is y, so there are 2 pi y, and then now the shell height is from here, from this one to that one. Now in x direction, this value is 2, and this one is now, okay, this is from curve y equal x squared. So that from this one, now x value is the same as, now from this one, x value is same as square root of y. We have to express the x value in terms of y, so that the height is now here 2 is upper bound and lower bound is now square root of y, right? And then y directional integration. Okay, so from here, now it's a simple 2 pi, and then now integral from 0 to 4 and 2y minus and y times square root of y, that is y to the 3 over 2, and here dy, so the same as 2 pi, and here y squared, antiderivative, and minus y to the 5 over 2 and 2 over 5, and from 0 to 4 evaluation. Okay, now you can finish the computation yourself. Okay, now find the arc length function for the curve taking pi over 4, 0 as the starting point. Okay, y is given in integral form. However, once you do integration, then there is a function of x. So we can write down f of x. Now, y equal f of x is given, then the arc length function s of x is defined in this way from starting point pi over 4 2x and square root of 1 plus f prime. Okay, let's try to use t variable and dt. That's the definition of arc length function. So here we have to find f prime. Okay, now f prime of x equals same as, now there's y prime. So that is now, okay, by using the fundamental theorem of calculus, we have here tangent of x times square root of 2 plus tangent and square root t. Oh no, we have to use x notation. Okay, over there, that is now x. Okay, so 1 plus f prime squared is the same as 1 plus now tangent squared x, and here 2 plus tangent squared x. So that is the same as here 1 plus 2 tangent squared x plus tangent to fourth power of x. So they're the same as 1 plus tangent squared x squared. Okay, so from this one, if we are taking square root, then this power square will disappear, so that the arc length function will be the same as from integration from pi over 4 to x. Now square root of that one, which is same as here 1 plus tangent squared t dt. Okay, by using trigonometric identity, it will become now sec squared t, and antiderivative of the sec squared is tangent of t. Right? Okay, so here now that is from now pi over 4, and that is x, so that is same as now tangent of x minus that is okay sec squared, so the tangent, so that tangent of pi over 4 is same as 1, right? Okay, so we reach the final answer, tangent x minus 1. Okay. Okay, and number 3, find the area of surface obtained by rotating the curve x is 4 minus y squared. Y is moving from 0 to 2 about the x-axis. Now, for this problem, again, what you have to do first is to understand the problem, and then now the surface is same as here 2 pi r and ds, right? So we'll use the formula. Okay, let's try to understand the problem. X is 4 minus y squared, and y is moving from 0 to 2. Okay, here we have, and x is 4 minus y squared. So once y equals 0, then x is 4. That is x is 4. And once x equals 0, then y must be 2. Okay, so the curve is given in this way. So that is now x equal 4 minus y squared. The curve is rotated about here x-axis, so rotated, and the surface will be made. Now we want to find the surface area. For this problem, you can do either x integration or y integration, and here the y value is given, and then now x is expressed as a function of y. so that y integration may be easier. Okay, so let's try to do here y integration. Y is moving now from 0 to 2, right? Okay, so it's from 0 to 2, and now 2 pi, okay, once it is rotated, then now here, and it's y integration, and then for each y, it's rotated with, okay, for each y, the point is rotated, which will make a circle. The area, the length of the circle, perimeter, is 2 pi y. R is now y. So we'll do y integration so that it'll stay there. You don't have to touch this one. And then, now ds, you have to put here now ds. Okay. ds must be expressed as, now as a function of y, so that ds will be the same as the square root of 1 plus x prime squared dy. Of course, prime is with respect to y. Okay, that is now square root of 1 plus. Now, derivative of 4 minus y squared will be here minus 2y squared, so the 4y squared dy. So that is the same as integral. Okay, we can go 2 pi in front of that, and then from 0 to 2, and y, and square root of 1 plus 4y squared and dy, right? Okay, so from here, 2 pi is there, and we have to find the antiderivative for that one. Okay, let's try to get it. Here, you can use u substitution. However, let's try to use the method of undetermined quotient. So that one is, okay, major part will be 1 plus 4y squared power 3 over 2, and it'll have a quotient here. To find this quotient, let's try to make a derivative for that one. That is now here, 3 over 2 will be in front of that, and then 1 plus 4y squared and half power times derivative of this one. Now we are using chain rule, so the derivative of this one will be 8y, so that this is same as now 12, and here that half power and times y. So we have extra 12. So here we have to put 1 over 12, right? Now, that is antiderivative, and we are evaluating from 0 to 2. So from now on is p sub k, right? Okay, let's go to number 4. Find the integrals. It's not so complicated. Here, we know that, and once we have 3 to the x, then for that function, if you are making derivative, then that is same as 3 to the x and natural logarithm of 3. So here, integration of 3 to the x will be now 1 over logarithm 3 and 3 to the x. But we have these things and x cubed, so that we may start with change of variable. Okay, u equal x cubed. Then from here, du equals same as 3x squared and dx. And now x is 0, the lower bound, then u will be 0, and x is 1, then here u will be again 1, so that the given integral can be written this way. Now u integration from 0 to 1. Now here u is x cubed, so that this portion is changed into 3 to the u, right? And then x squared and dx, that is now 1/3 of du, 1/3 of du. So let's rewrite this one. 1/3 can go out, and from 0 to 1, and 3 to the u du. Okay, 1/3 is here, and antiderivative of 3 to the u is the same as 1 over logarithm 3 and 3 to the x. Okay, now you can evaluate from 0 and 1, so that that is same as, okay, and once 1, the value is 3, and the 0 then is 1, so that this portion will be 2, so that here 2 over 3 and times 1 over logarithm 3. That's the final answer. Okay. Now for this problem here, and logarithm, okay, logarithm of general a base and x, that can be written here logarithm of x, natural logarithm of x over natural logarithm of a, so that once we try to make a derivative, then that is same as here 1 over x natural logarithm of a. This portion, natural logarithm of x, its derivative will be 1 over x. So we reach at that one. Okay. Okay. So here, for that problem, what if we start with change of variable? For example, u equal now log base 5x. Then from this one, du equals same as 1 over here x and natural logarithm of 5. We already know its derivative, and dx, right? And x is 1 over 5. Then now here, okay, it's 1 over 5. Then u is now minus 1. Now here the x is now 5. Then here that is now u is 1. So the given integral is the same as from -1 to 1 integration, and then now log 5x is changed into u, and 1 over x dx, 1 over x dx is same as log 5 du. From this one here, now from this one we can get here now, okay, and 1 over x dx is same as natural logarithm 5 du, right? Okay, so 1 over x dx is changed into that one, so that is now, okay, log and 5, and here we have now du. Okay, that one, that is log 5 will go out, and -1 to 1 u du. This is symmetric interval, and this is odd order term, so u, and so that the integration must be 0. So here we have 0. That is the final answer. Okay. Okay, number 5, solve the initial value problem. Okay, this is a separable equation. So we move everything, every term, including y, to the left-hand side, and everything, including x, to the right side. Then, from this one, okay, now y squared plus 1 is changed into 1 over y squared plus 1 on the left-hand side. Except that, okay, dy, okay, now right side, x will go to the denominator, so that x plus 1 is there, and x, and we have here dx. Okay, it can be written in this way, 1 plus 1 over x, now dx. So we apply integration. Then for this one, if you make integration with respect to y for 1 over 1 plus x squared, then that is same as here arctangent, right? So that is a tangent inverse of y. And right side, antiderivative of 1 is x, and antiderivative of 1 over x is a natural logarithm of here absolute value of x, and that is now c. Okay. Here, it is defined on the right side, and x is 1, y equal 1 is the initial value. Okay. So here, we should decide the c by using data. That means that once x equal 1, then y equal 1. Okay? So use that. So that is now arctangent of 1 equal 1 plus, now that is 0 plus c. So that arctangent to 1 is pi over 4, right? So that is pi over 4 minus 1 equals c, right? So we can finalize the solution. There is an arctangent of y equal x plus, now we don't need absolute sign, so the natural logarithm of x plus here pi over 4 minus 1. Okay, that's the final answer. It is implicitly defined, but that is the answer. Okay. Okay, here we have table derivatives of hyperbolic functions. This table will be given to your exam. Now we want to get here the evaluation of the integrals. Okay, for this one, if you're using change variable, for example, u equals square root of x, then here du is the same as now 1/2 and 1 over square root of x dx. So that, okay, we can rewrite here now, because 1 over square root of x dx, so that 1 over square root of x dx will be the same as 2 du. Okay, with that, the given integral can be written in this way. Here, now that is u, so it is a sec hyperbolic, now square u, and now the other part will be twice of, okay, let's put 2 outside and du. Now, by using here formula, here sec hyperbolic squared, its integral must be tangent hyperbolic. So that is same as 2 and tangent hyperbolic of u and plus c. What is u? U is square root of x. So that's now 2 tangent hyperbolic square root of x and plus c. That's the final answer. Okay. Now for this problem, and here cosine hyperbolic logarithm t plus 1. Okay. So for that one, here we may also try to use change of variable, u substitution. For example, u is now natural logarithm t plus 1. Then du equals same as its derivative, which is 1 over t plus 1 and dt. Okay, this portion will be later changed to by du. Okay, Now, t is 0 implies that now logarithm 1, so that u equals 0. Now, t is e, then here, now there's e plus 1, so it's a logarithm, now e plus 1, okay? But anyway, that is a number, even though it's a bit complicated. Okay, so given integral is changed into from 0 to natural logarithm e plus 1, and then this portion is now cosine hyperbolic, and there's u, right? And then remainder part, and 1 over t plus 1 and dt, that is now du. Simply. Okay, here, now for that one, cosine hyperbolic its integration must be sine hyperbolic, right? So that that is the same as now sine, hyperbolic sine u, and u is from 0 to natural logarithm e plus 1. Sine hyperbolic 0 is 0, so that there's now sine hyperbolic u. U is now natural logarithm of e plus 1. Okay, like that. That's the final answer. Okay, that's the end of the review for exam number 2. Thank you.